Number 13. Given two functions, g of x equals the square root of 6 minus x. All right. Find f composed to g of x. Now that's like saying f of g of x. So we're going to take g and plug that into f. We're going to take g and plug that into f, where that x is. I'm going to put parentheses around the x. So parentheses, that x becomes this, 6 minus x squared plus 2. Oh, don't forget, I almost forgot about the absolute, or the radical symbol. The power of 2 and the radical kill each other off, and you're left with x minus 6. Oh man, 6 minus x plus 2. And the 6 and the 2 will go together. Give you that. Okay, so that's our answer. Now, part B asks to find the domain. Now, if I skip everything I just did and say, oh, look at here. The domain of that is all real numbers. That doesn't really tell you the whole story, because, look up here, before you cancel off the power and the radical, you actually had to subtract x away from 6 and then take the radical and then take the power. Right? That's how order of operations work. So the domain of this is actually more complicated than just saying all real numbers. You have to go back to here. This is the problem right here. You got to make sure that this works. Basically, you can't have a negative under the radical. It must be greater than or equal to 0. So let's subtract the 6 away. I always like to keep the x on the left for some reason. We'll divide by negative 1. Now, remember the rule that if you multiply or divide both sides by a negative, you have to flip the inequality symbol. So x must be less than or equal to 6. So, and that makes sense, because what's a number less than 6? I don't know what I put negative 6 for. What's a number less than 6? 5. 6 minus 5 is 1. That's a positive value, right? Your values have to be less than 6, because you're going to subtract it away from 6. So the good thing, though, is that this can handle it. The domain of this is all real numbers. It can handle anything, and it's going to give you that. So the domain would be this guy right here. All right, now if I flip that around, if I change it from f composed of g to part C, which is g composed of f, that will change things around. So f of x goes into g. F of x is now going to go into g right there. Okay. Let's put a little set of parentheses around that. It would be absolute value of 6 minus, and then f, which would be x squared plus 2. Alrighty. And then we can distribute a negative 1 inside there if you want. It wouldn't be a plus 2, would it? It'd be negative 2. And then 6 minus 2 would give you, 4? Plus 4 is the positive. So there's my composite function. Now, domain. Let's think about this for a second. Function f, everything that you plug into f. All right, so what's the domain of f by itself? Remember what f of x was? X squared plus 2. Everything that goes into f. Well, you can plug a negative value in or a positive value in. It doesn't matter. This is all real numbers. So the domain of this is all real numbers. What's the range of this? What's all the outputs? Because what happens is all the outputs of this go into G. So what's the range of this? Well, it's a parabola, right? And the range of a regular parabola is from 0 to infinity. The plus 2 moves it up 2 spots. So your range here is 2 to infinity. Okay, well, looky here what's going to happen. 6 minus 2, 6 minus 3, 6 minus 4, 6 minus 5, those are all fine. I'm going to get positive values. What happens when I get to 6, 7, 8, 9, 10, right? That's the range here. Those values are in there. So I'm going to have some issues. I'm going to have issues. So let's take what's underneath the radical here. Negative x squared plus 4. Let's say that has to be greater than or equal to 0. So since it's just 1x squared, I'm going to move that over and say negative x squared is greater than or equal to negative 4. Divide both sides by negative 1. Remember what happens when you divide by negative 1? It's going to flip that around. I'm going to take a square root, and I get x equals less than or equal to plus minus 2. Positive and negative 2. So my domain here would be from negative infinity to negative 2, negative 2 to 2, and 2 to infinity. Think about it for a second. What's a value that's in this interval? Negative 3. So what happens when I plug negative 3 into this? Well, negative 3 eventually would first go into function f. So negative 3 squared is 9. 9 plus 2 is 11. Then you're going to plug it into g. It's 6 minus 11. That sucks. That ain't going to work. Okay, so what about this interval? That ain't going to work. What about this interval? From 2 to negative 2 to 2. What would be inside here? Say 0. 0 is inside there. If I plug a 0 in here, what am I going to get? 0 squared, which is 0 plus 2 is 2. And I plug it into g, 6 minus 2, which is 4. That works. That works. So this interval works. And what about this interval from 2 to infinity? What about 3? 3 would be a value here. Well, let's plug 3 into f first. 3 squared is 9. 9 plus 2 is 11. 6 minus 11 is, negative 5. That can't work. So that's not part of the domain. So the only part of the domain would be this guy right here, from negative 2 to 2. That's how we solve these inequalities, remember. You got to pick test points.